What is this truck carrying? What kind of ore will it deliver to the processing plant? How does one control the quality of the mined ore? Ore quality control is the most important task of the mining and processing industries. But how can one determine the elemental composition of large masses of ore that is being transported on a conveyor belt? Chemical analysis requires a tiny sample, which must be dried and crushed to fractions of microns. X-ray methods provide information on the elemental composition of only a few millimeters on the surface of the ore. A new method of analyzing rocks using a tagged neutron method was developed by the Dubna-based company Diamant, a resident of the Skulkova Innovation Center. To find out the elemental composition of a substance, it is irradiated with 14 megaelectron volts of fast neutrons, which excites the nuclei of the substance. The excitation is removed by the emission of hard gamma quanta with energies of 1 to 7 megaelectron volts, the spectrum of which is unique for each element. These act as the fingerprints by which the presence of certain elements in the sample is recognized. It is important that the method of using fast neutrons and hard gamma quanta provide a high penetrating power. It allows us to determine the elemental composition of the substance, even hidden in sea containers. A neutron is always born with an alpha particle. If you tag a neutron, by registering its direction with a special detector, then you can find out the direction in which it is moving, and by the time of flight, you can determine the exact place in the substance from which the gamma quantum was emitted. If conventional neutron analysis methods can be compared with the irradiation of a substance by a neutron lamp emitting light in all directions, the tagged neutron method creates a neutron laser pointer that explores only this area of the object and thereby reduces the background noise from the environment 100-fold. A stationary version of the ore analyzer based on the tagged neutron method is implemented in a separate module containing a neutron unit. The office space, which contains the module, is equipped with a climate control system and can be placed directly in the quarry or in other field conditions. A sample weighing up to 10 kilograms is placed in the receiving tray of the module without any sample preparation. The sample size can range up to 300 millimeters. The humidity of the sample does not interfere with the determination of the elemental composition. Sample analysis is carried out automatically. At the same time, concentrations of up to 10 oxides can be determined. For a 6-month period, the module was placed and operated at the Vostochny mine of the Kirov branch of Apetit JSC. Tests of the module were also carried out at the Kovdorsky GOK of JSC Yevrochem. The conveyor version of the rock analyzer enables the installation of a neutron emitter under the conveyor belt. The material of the conveyor belt is not an obstacle for fast neutrons. Gamma ray detectors are placed between the guide rollers around the conveyor. This configuration is the most convenient for installation on existing conveyors. At present, the method has successfully been tested to determine the elemental composition of phosphate ores. However, it can be used to determine the composition of up to 24 elements. This is only the beginning of the systematic study of the capabilities of the tagged neutron method.